camera, ma'am. Thank you.
Yeah, sure.
A very good morning, ma'am. Good morning, all who have joined now. Very good morning to everyone. So we shall start the session. So we are on the second day of AICTE sponsored induction preparation program for engineering faculty people on the title FPGA for Low Power IoT. I take this opportunity to introduce our session guest, Dr. G. Janaki, to the participants. Ma'am, my slide is okay?
Yes, ma'am.
Dr. G. Janaki completed her bachelor's degree in electrical and electronics engineering and master's degree in power electronics and drives and PhD in faculty of electrical engineering from Anna University, Chennai in the year 2015. She has more than 15 years of teaching experience in various engineering college as HOD, and after 2015 she has joined in IIT Madras Joint Teaching Learning Center and served as Senior Project Officer under the scheme of Pandit Madan Mohan Malaviya Missions on Teachers training sponsored by MS Hardy in India. So she is a key resource person to handle the sessions on pedagogical techniques, technology application in pedagogy, large classroom management, digital classroom, introduction to TPAC, e-learning, introduction to LMS, flipped classroom, outcome-based education, ICT-enabled education techniques for various faculty developments and faculty induction programs. She is currently working as Assistant Professor, SRM Center for Applied Research in Education, SRM CARE, Kattankulathur Campus, and her areas of interest includes wireless power transfer, electrical vehicle, machine learning, EMI and EMC analysis, power converters, drives and control, and innovative instructional strategies in engineering education. She has also published textbook and in the title Power Electronics and Drives, published by Ishwa Press, and she has more than 25 research papers to her credit, published in international journals and conferences. We are very much pleased to hear, ma'am, on behalf of SRM Valliammai Engineering College, Department of ECE. I welcome you for this session, ma'am. Now you can take over the session and you can present your thoughts to our fellow faculty members, ma'am. Thank you, ma'am.
Sure. Thank you so much. Thank you so much for the nice introduction, ma'am.
Thank you so much, ma'am. And I request the participants to be very interactive for all the sessions. So the feedback what I had from yesterday's ma'am was that we are not reciprocating the content. Please make sure that we are alive in online at least by interacting with them. And ma'am will make sure, Janaki ma'am will make sure that and we can proceed, ma'am. Thank you, ma'am.
I try my level best, ma'am.
Yeah, ma'am. Sure, ma'am.
Thank you. Thank you for the nice introduction, ma'am.
Thank you, ma'am.
Okay.
You can start your presentation, ma'am, I think.
Yes, ma'am. Is my voice is loud and clear, ma'am?
Yes, ma'am. It's clear, ma'am.
Okay. The screen is visible, ma'am?
Yes, ma'am. Visible, ma'am.
Shall I proceed? Shall I proceed?
Yeah, ma'am. Sure, ma'am. Sure, ma'am. We can proceed, ma'am.
Yeah, thank you, ma'am. So, very good morning to one and all. And today's topic is FPGA in IoT, a technical paradigm. So, we are going to see an overview of how the FPGA is applied in IoT. What are the different areas, how this FPGA is applied in different layers of IoT. That is the main agenda of today's session. So the outcome is, at the end of the session, every one of you are able to describe what is the role of FPGA in different layers of IoT. So this is the outcome for today's session. So before we start, can you just think for a while and tell me what is IoT is? Hopefully you all know. And I want the reply. Anybody can unmute yourself and you can say, or otherwise you can give it in the chat box.
So Usha ma'am from Sairam has noted that connecting devices together through internet. Ma'am, you are able to read
Yes,
our
ma'am.
boxes, ma'am? Yes, yes, ma'am.
No, I can't. Yeah. Thank you, Usha ma'am. Connecting devices together through internet. Okay, thank you. And any other thoughts for what is IoT is? Any other thoughts from other participants? Just now, ma'am said be interactive. So I request the more interactions from all the participants. I think yesterday you met our sessions on IoT and FPGA. Could you please share your thoughts on what is IoT is? Okay, fine. So thank you, Usha ma'am, for your response. So as you rightly said, it's an interconnected devices which transfers the information through wireless network to the cloud, and we'll process or we'll take actions based on the informations what we processed. So without any human interventions, we do this. That's what we call it this as an Internet of Things. It's fully automated. Okay. And if you see, this is IoT devices, and from IoT devices, we'll collect the real-time informations like signals. It will be mostly like sensors and actuators. So we'll gather this real-time signals, and it will be passed through IoT gate through this wireless network. And this processing node or the IoT gateway will process the information, and it will store it in the cloud. So the cloud acts as both the role as a storage as well as the processing unit, where based on the informations it gained from the real-time system, it will process and it will decide what actions to be taken. Okay, and also it stores the information or the actions what it's performed for further learning as well as for inferences. Okay, this is what the entire IoT system is. Because of the large response and the monitoring and analytic capabilities of IoT, and it is adopted in almost all industries in all areas. Because of this, this will be a promising area for near future. Okay, so in near future, the IoT, we can say it will rule the world. Okay, so the applications of IoT. So now, can anybody tell what are the applications of IoT?
Smart home.
Can you tell me what are the applications of IoT? Few applications of IoT.
Smart home, ma'am.
Smartphone, okay. Then
Agricultural field.
agricultural field we can use. Thank you. Then where and all we are
automatic
finding.
control automatic control where as
Yes,
such as like if we want to control our room with by
yeah,
remote,
home automation.
so
Yeah,
that we
yes,
are using sun sensing devices.
yes, ma'am. Home automation. Thank you. Then
Yes,
agriculture field we are using home automation. We are using smartphones, smart cities.
yes,
Then
right.
any other thoughts? In industries we are using the fully automated industry, we are using IoT. Healthcare
Traffic
center, thank
controls
you.
or as well.
Yes, healthcare centers, even the communities centers,
Yes,
even for
yes,
security systems, we are using IoT.
yes,
Okay,
yes,
even for
exactly.
database and banking sectors. Okay, so IoT
Right.
finds applications almost all the fields. Okay,
All these
so
things.
so you can see here, so home automation where it for controlling all your home appliances and for security as well, and for transportation systems and for logistics and all we'll be using for community, even the retail shops. You can use IoT even for surveillance, factory environment, and even for in defense also we'll be using IoT. In industries, the policy makers, they will, based on big data, they'll find and accordingly they will make policies in the systems. And home automation is already someone said, and even in healthcare departments, we'll be using IoT applications like to keenly monitor the patient's conditions. We'll be using the application of IoT. Okay. So let's see what are the technological traces of IoT. So initially, it is not called as an IoT. In the year 1991, the Mark Weiser, he first introduced a small work on how the human-machine interactions will be. So that is the beginning of the IoT, probably we can say. And later, based on these human-machine interactions, the industry people started working on how the machine-to-machine interactions happening to in order to do the automation in their industry sector. So based on this, machine-to-machine interaction is introduced. And later, in the year of 1999, Kelvin Alston, he presented in his presentation during, he belongs to Procter and Gamble industry, and he's presented how the IoT can be introduced for automating their industry. So that was the, we can, it was recorded as a first IoT project ever comparatively, and based on that many researches are going on. And in the year of 2019, according to the Cisco Commerce estimates, it is stated that 2008 to 9, it's almost the number of connected objects was almost exceeded the total world population at that particular time, which is around 6.7 to 6.8 billion. Within a year, you won't believe it, it has become doubled. So it is almost around 12.5 billion connected objects. So that much widespread of application has been found in the world industry. So because of this, market price also goes up to around $150 billion. And it is predicted in the in 2024, the connected objects may exceed up to 30 billion. Okay, so that's the huge trend or the need of IoT in our day-to-day life, because people are looking in for fully automated, and they want all the operations or the functionality to be done at a very faster rate. That's why they are all switching over to IoT. So again, while we switch over to IoT, we need to know how the architecture is, right? So basically, the architecture has only three layers. We'll say a perception layer, network layer, and application layer. Rather, we can see it as the infrastructure, the network layer, and the edges we'll say. Okay, so the perception layer is nothing but the actual sensors and actuators, or where we want these signals, actual signals. So all comes to the physical layer. Rather, we can say the physical layer of architecture is nothing but the perception layer. And although from the data which we collected from the physical layer, we will be retrieving the information and we have to process it, right? So for that, we need a network. So it could be either wired network or it could be wireless network. Most of the time, we prefer wireless network. For example, your Zigbee network or your Bluetooth or Wi-Fi or now Z-Wave network is there. So the different network layers. So these network layers will collect the information, or probably we can say this is a gateway, and this again it will give it to the cloud, and the cloud, which consists of all the processing information on your software part to decide on what you have to do with the data which you retrieve from the real-time environment. Okay, so that's what the application layer. This is the general architecture of an IoT. So nowadays, because of the requirement or the demand increases, we have the other two types of architecture also. So here we can see here SOA, which is nothing but service-oriented architecture. This is nothing but, see, in between these three layers, we have added one more layer as service layer. This service layer will provide the information about what you want the third party or the consumer required to know about the details about the particular operation of this informations. So this becomes the service layer. Okay, this is again a software which actually do the set of processing or conversions so that it will be user friendly. The data will be user friendly. Okay, so that is what it does, the actual servicing. It is actually not showing your sensor details of that and all. Whatever the person needs, for example, the location of a vehicle, if you want, if you have a very big yard in your industry where there are a lot of vehicles available and you want to know the information about a particular vehicle, so actually that require that query you can give it to the system, and the system will track where the location of the vehicle is, and it will give the details where it is actually. So that type of thing is a service level. Instead of you really go and search, it will give this is the lane, this is the track, or this is the floor, or this is the location where you can find this particular vehicle. So that sort of service oriented operations, you can slightly modify your software part so that this will be apt for your service oriented operations. Okay, so that is what we call it as a SOA, service oriented architecture based architecture. And again, in between that, here we have a middleware based architecture where between this service layer and the application layer itself, we will be having one more layer, we call it as middleware layer, where it will do all sort of conversions, like analog to digital conversions or something like that. And again, it's a program only. So all these layers, the middleware layers, not an hardware, it's just a software according to the requirement of the stakeholder. The person will, the IoT industry people will modify. It may be like a small app. Okay, so like that they will make it. This is what is middleware based architecture. So any doubt? Shall I proceed, or any queries at this juncture? The architecture of IoT. Shall I proceed? Is it fine?
Yes, ma'am. We can
Any
proceed.
queries? Yes, okay, thank you. Okay, so now can you tell me, we know the architecture and we know where and all it will be applicable. Okay, so now can you just think how we can do some innovations if we want to do some innovative things, or if you want to take up a research in IoT based, how you can bring in the innovations in the IoT field. Can you just think and share your thoughts? Or the areas to do research in IoT, or how you can bring in innovations, or what is the scope for doing research in this IoT field? Is the question is clear? Dear participants, is the question is clear? Networking. Okay, networking trying to make easy. Okay, thank you, Vanu sir. Any other thoughts? What are the technology integrations will bring in innovations in IoT? Can you think in that aspect? Software development. Okay, software development in the sense. The programming or the languages, do you mean? Okay, so what technology will be apt or well suited to do innovations in IoT? What sort of technology? For example, if I take a retail shop application of IoT, what type of technology will be helpful? Or if it is a banking sector, what type of technology? If it is a weather prediction, what type of technology will be suitable for doing innovations in IoT? Any other thoughts or any other inputs? Thank you, and Anu sir. Don't be sorry because we are all in learning phase. So don't hesitate to give your answers.
Final semester.
Yes, ma'am. Hello. Any inputs?
No, ma'am. Ma'am, just mute all
Okay.
and I'll unmute only you, ma'am. Please check it, ma'am. Okay.
Okay.
I'll, for a few minutes, I'll mute all.
Okay, fine. Thank you, Anu sir, for your input.
1 minute, ma'am. One minute, ma'am. Ma'am, I'm not able to unmute you. Now you are able to talk, ma'am.
Ma'am, are you able to hear? Are you able to hear, ma'am?
The Janaki, presenter of
Are you able to hear?
the voice. கேட்கல.
Ma'am, கேக்குதா?
Ma'am, now it's okay, ma'am. Now
Okay,
ma'am.
ma'am. Okay. Sorry for the interruptions. So you can innovate by adding different technologies like cloud computing, machine learning, artificial intelligence, big data, deep learning algorithms. So with these kind of new innovations in the technology, you can bring in innovations in your IoT applications. Okay. Now, can you just think what are the challenges you'll face while implementing IoT? What are the challenges you'll face in IoT? Participants, can you just think and give your response in the chat box? What are the challenges you'll face in implementing IoT? Is the question is clear? Please respond to chat box. Participants, please give your response through chat box. Battery lifetime of sensors. Well said, Abhirami ma'am. Or we can say the energy or the power requirement. That's a major problem we face. Stability, accuracy. Okay. Any other thoughts? Stability in the sense, what do you mean? The entire system stability or the network stability? Sensitivity. Okay. So you mean to say the compatibility? How long it works? Yeah, that matters. That needs more power. For the longer operation, it needs more power, right? Many of you joined the chat, but you're not responding. Interconnectivity, right? Okay. Any other thoughts? Working is easy. Data security. Thank you, Suresh Kumar sir. The security is a major problem when we looking for IoT. Okay, so because we have to secure all the data, so the security is one more alarming issue in IoT. So employment is easy. I couldn't get you what you want to convey. Working is easy, employment is easy. Okay. So any other thoughts? As you said, the battery power is a problem, security is a problem, and the connectivity is a problem. Okay, so let's see what all the other challenges. Thank you all for your response. So the challenges you see, as you rightly said, the power consumption, and because the enormous growth in the connected objects, the interconnectivity is again a problem, and interoperability of across the different interfaces, that also it's a problem, because that should be compatible. It should be, the sensor has to be properly connected through proper network, the analog signals has to be properly converted to digital, and if we are increasing, if we want a higher operational speed, then we have to change the processor, and the processor should capable of handling those informations. So if we are changing the processor, and again the whole system or the program has to be compatible, so the compatibility is an issue, and again availability of the network coverages and the security. These are all some of the challenges we face while implementing IoT for any applications. Okay, so now just think how we can overcome, or what is FPGA, how this FPGA will overcome the challenges in IoT, why we are talking about FPGA and IoT for low power IoT and all. Okay, just think what is FPGA, obviously you know. Okay, why FPGA technology and how it could overcome the challenges in IoT. Can you please think and share your thoughts? Hope the question is clear. And FPGA, you all know, it's a field programmable gate array. So just think or spend time to think on the other two questions. Why this FPGA technologies, how it will overcome the challenges of IoT. Can you please type it in the chat box for this question? Why FPGA technology? Scalability, well said, ma'am. Yes. Okay. Anything else? We can implement our own design. Yes. It's configurable. Well said. Well said, Saravanakumar sir. Even it is reconfigurable also. In due course of time, if you want to change your processor, or if you want to change your system components, and again you can reconfigure it. Sensor. Okay. Yeah, because of the reconfiguration capability, we could use it. Okay. So any other thought apart from scalability and design configuration? The main thing is power, right? So because when we're talking about the challenge, we talk the first constraint is the amount of power requirement, and when compared to the other devices, FPGA power requirement is very low. That's what the title of the, I think, the FDP, the induction program itself. It's for low power IoT. So because of the low power consumptions, it can long last for a little more time. So the period of battery operating time also gets extended. Okay, so that is the main idea. And if you're going in for ASIC design and all, like application specific integrated chips and all, though it is for a specific program, and if you want to modify any one of the tasks, and then you have to do the complete modification of your network. And again, the design part is simulation part and all, it's fine with ASIC. When it comes to the real-time application, it takes longer time to actually fuse into the real-time application. But that's not the case for FPGA. So once if you deploy the development board, FPGA development board, according to your requirement, you can customize at any point of time. That gives you flexibility in your entire application. So that is the main reason why we are all switching to FPGA for IoT applications. Thank you all for your response. Okay, so as I said, it's a field programmable gate array. It's an integrated circuit which you will be having so many CLBs, that is configurable logic blocks. So based on your requirement, you can reprogram it and use it for your application. Okay, so that's the beauty of this. Around 100 to 2,300 configurable logic blocks are available the current development boards. And important characteristics, as you see here, the lower complexity, and works in a high operating speed. The clock speed is very high, and the execution time is also very less for any operation. And the volume of design, because of 2,300 CLBs are available, so you could modify according to your convenience. Customization is very easy, and it's programmable function is also it's easy. And you can, through your Xylem program, you can just do the modulations, and you can fuse it, and you can readily deploy it for applications or action. Okay, so that's the beauty of FPGA. So as we said, the performance, and it will do parallel processing, and the number of clock cycle required is also it's the time is very less. It's a faster operating speed you'll get. Okay, and time to market is also it's very faster thing, and because of the flexibility and rapidity, the prototyping overall can be done at a faster rate. And the cost is less when compared to ASIC, and definitely it will be a bit higher than the processor rate. Okay, because of the features, alien features, definitely the cost is higher than the microprocessor. Okay, because it has both your IO units, your network analyzer, that is your Bluetooth or Wi-Fi, or your USB, everything will be in there integrated in the one development board or FPGA board. Okay, and because of parallel operation in the high speed, definitely the power consumption is very less, and it has a capability to go into a sleep mode when it is inactive. So that itself will save so much amount of power in your circuit. So that is why we are all moving on to, or we are looking in for FPGA in the IoT industries. Is it clear? Any clarifications required at this moment? Shall I proceed? Any clarifications or any doubts in the chat box, ma'am? Okay. So as we said, the low power, because of low power consumption, it finds a way, and because of parallel processing, it handles multiple sensors simultaneously, and it is suitable for high performance application. And even for this image processing and all, these HDMI videos will be very much helpful for doing all sort of this video capturing or image processing applications and all. And it will be a good emulator of your it will be, we can call it as a system on chip. Okay, there are different options for FPGA. So generally we'll have Xilinx Ultra, and AICTE Tizon is there, and AICTE with HES with Xilinx Ultra will be there, and Vertex 7 2000. So this Vertex 7, it will have, you'll be having 2300 CLBs are there with the Vertex 7 2000 boards, application boards. So if this is your FPGA, and it can be connected to any of the sensor or connected to the phone through apps, and it can be connected to web server, you will be having your USB mode where you can wire your sensors or your devices, and you will have Z-Wave sensors. Okay, so these are all different FPGAs, boards, development boards. You can use it for your applications. Okay, let's see the role of FPGA and IoT. So it is, as we said, the basic layer of IoT is three layers, right? Like perception layer, your network layer, and then your application layer. So here it's similar to the perception layer is nothing but this edge where the sensors and actuators are the physical layer, and this is the gateway, or where you'll be using your FPGA as an IoT gateway. So for reference designs, you can use either Bluetooth, or for networking, you can use anything Bluetooth or Z-Wave or Zigbee sensor, or for wired application, you can use USB, or you can use LAN or WAN, you can use Ethernet cables, you can use, okay, and you can use your cameras and all. So all these things, you can use it as a gateway for IoT. For infrastructure, the processing units you will be having, it can, the FPGA itself can act as a virtual machine. Okay, so that is called the data processing. You can write your programming, machine learning algorithms, and artificial intelligence algorithms, and this itself will act as a node. So FPGA, you can use it for processing. Like you can say, before the application there, you'll be having some service layers kind of thing, right? So for that, you can use your FPGA. Okay, so if you see here, this is in AICTE Tizon FPGA link. Okay, so here if you see, there are different applications. All these are connected to the Amazon Web Service, AWS Cloud. Okay, and you can see different actuators and sensors connected to the board, and all these are um, processed through the algorithm, and the cloud will collect all the data stored based on the data and your references. It will compare and it will give the commanding action or the decision action. So accordingly, the actuators will operate, and the devices will be functional. Okay, so this is how we can use this FPGA in the IoT. Okay, so it's just a block or a representation of how we can implement this FPGA in IoT. So if you see, the main features of this Tizon is it has a dual core ARM Cortex, and it will run the software, and it has custom hardware, and it has for wireless communication network, you will be having Wi-Fi and Bluetooth, and for wired network, you will be having USB and Ethernet. IoT gateway reference, the operating OS is Linux OS, and it has graphical user interface also. And all the edge devices are connected to either Bluetooth, Wi-Fi, or USB, or a Z-Wave. Okay, and you have separate. No need to actually bring in your separate cloud unit or server. You can use the Amazon web services for storing all your data and processing your data. And also it provides some web server applications to actually do all sort of services or business thing. And Android end user, that is, you can also convert that as an app. So through your GSM, you can control your input. Okay, input or output, whatever you want to control, you can control it. So you'll be having, as an end user, you have an app application part also. So which is GSM based app, you can get it. Okay, so this is the feature of this Tizen Xilinx Zinc processor. Okay, so here we can use it in different modes. As we have said, you can use it for just monitoring the data also. So for just monitoring the data, you will be having your FPGA, and which will be connected to the different sensors. Excuse me. Okay, so it will be connected to the different sensor to this I2C cable, and this FPGA, again, it will store or it will process according to your configuration. It will measure the data and it will store it in the Amazon cloud, the AWS cloud. Okay, so it gives a significant power saving. So because of that, it has a very low power, so it's a longer battery life. Display time is also longer display time, and very lower thermal radiations. So because of that, the amount of noise coming out is also less, and it is also compatible with EMC, like electromagnetic compatibility. Okay. Then comes the processor companion. Processor companion of FPGA, you can see here. The CPU, if you have, this is an FPGA. If you want to increase your display time or the display driver, want to improve the time of your display, you can see here the display driver and LED drivers and all. Here you have different voltage levels. Here it is 3.3 volt, here is 1.2 volt, here it is 3.3 volt. So according to the requirement of different voltage levels or different compatibility, you can configure your FPGA and you can connect to the processor. Whereas if you use an application specific or an ASIC thing, you have to design 4 different boards for all these actuators, okay, or all this type of objects. We call it as things in IoT, right? So whereas here, that's not required. Even within a single board, you can configure according to your thing. That is what we call it as a processor companion FPGA. Okay, so any doubts so far? Any doubts? Any doubts? Shall I proceed? Okay, fine. So it's you will be having a new type of memory, and the number of IOs you can expand based on this your requirement. Okay, so this is what we call it as a processor companion. Okay, here comes the IoT gateway applications. Now we can see here, if you take the processor, okay, in this you can see different applications. Like, can you tell me what is IoT gateway is? Then I could able to explain. What is the role of gateway, IoT gateway? What is the role of gateway in IoT? Connecting devices to cloud. Thank you, sir. So actually, we have a same cloud. Okay, for example, if too many vendors are using the same Aldec Xilinx board, and they'll be using for different operations. They should know from where the data is coming. Like, you should know your proper IP address, okay, and you should know where you have to store, and from where you have to pick the data, where you have to process it. Okay, so for all those things, you need a different what you call the gateways or the protocols. Okay, so based on this TCP/IP protocols, you'll be writing your program, and for writing the program, you will be having different. For example, for the same, you can use it for controlling the temperature of a boiler, or you want to measure the pressure. Okay, there are different inputs. So for that inputs, how you could able to do the compatible do the processing, and how you could give it to the processor in order to take a correct decision. So we need to analyze and do the programming. Okay, so for that only we'll be using this. So if you see here, you will be having the JTAG board, where you can actually do the simulation kind of thing. You can connect your hardware and you can simulate it, and you can run, and then you can fuse it to the processor for doing all sort of applications things. Okay, so here for configurations, you will be having some flash memory here, and you have UART, and you will be having your signal conditioning, like the analog signal, how it will be converted into digital signals, and how you can again do the processing. All this logical information, the combinational logic circuits you will frame, and finally you will fuse it. You can fuse it in your FPGA and complete your application, your programming. Okay, so this is what IoT gateway application is. So using different layer where you're looking in for, you have to change your what do you call the program logics. Okay, so now we'll do a small case study about how the smart hot is working. So actually, if you see, it's a smart hot. You can see the this is a small chain-like thing, or it's a necklace, where it will be wear by the it's a wearable device which will be wear for the person who is under risk, the cardiac risk, and it will continuously monitor the ECG. Okay. Similarly, you can do it for EMG, or for a muscular motions. If you want to monitor, you can do it for anything. So for here, this is application is for a cardiac people. So for a continuous monitoring of cardiac people, the EEG has been monitored continuously, and it is capable of storing around 24 to 28 hours. On these signals will be again going to the cloud systems, where the healthcare professionals will be looking into their profession, the person's health conditions, and based on that they can do the analysis, or they could diagnose what whether the body system is functioning, the heart is functioning properly or not, and based on this they will either they will prescribe the medicines, or they will monitor the condition of the patient. Okay, and it will not disturbing also, and pacemaker, if you see the pacemaker, they will be fixed into the it will be fused into the human body, and you have to be very cautious when you are going into the area where you will be having a lot of interferences, that and all. You have to be very careful, right? Whereas here, based on the data, it is not actually fused into the body. It is there, it's like a wearable, and it is very comfortable also, and doesn't require any sort of surgery kind of thing, and it's very easy to use it also. So if you see, the front end is a microprocessor, but the back end, what it is using, is a FPGA. So it's a multi-channel signal processing unit, and it has a portable assembly also. So if you see, this is the body where you will be placing all your electrodes. Okay, the ECG monitoring electrodes, and these electrodes will get the information as what do you call, the analog signals only. So that analog signals will be given to the differential amplifier. So again, it will process it, and it will measure the actual voltage, and that voltage is again given converted into digital signal, and that will be given to the FPGA through the serial line, serial communication line. And the FPGA, if you see, so that will be the digital input will be given to the FPGA or ASIC. So here we are not going in for your ASIC, we are considering the FPGA. So this FPGA will be given to this will process the data, and this will be given all those data to the cloud, Amazon cloud. Okay, or otherwise through, if it is the your Tiscom board, it will be Amazon cloud, or otherwise if you have a separate server, it will be stored in that particular place. And by seeing that, you will be getting a lot of information. You'll be connecting the data. So based on the data, the people will be knowing what actually you have to take, what type of action you need to take, and what is the history of that particular patients, how many times the BP is normal, how many, when it has gone high. So that sort of analysis will be very helpful for diagnosing the actual disease, and giving some sort of treatment to them to get cured. This is an example of this FPGA application in IoT. So any queries at this moment? Any queries? Okay, thank you. What is the work of front end? Okay, thank you, Saravanakumar sir. Because in the front end, it will be, for example, if you see it is in healthcare professional, if you want to see the data, what is the ECG value at that particular moment, what is the thing. So for that, if you want to feed some of the data about the prescription for this, what is the what do you call, at this particular date, you want to know the history and all. So this will be like a front end, like all the information, it's a service provider kind of thing. All the informations will be available at front, but the processing and all will be done by the FPGA only. I didn't get to. Programming is required, so on which platform it will be more easy. What programming you're saying, sir? Anu sir, I'm not getting your query. programming is required, so on which platform it will be more easy. Saravanan sir, did you am I answered your question? What about Anu sir is saying something, programming is required. See, if even if I'm saying it's an application layer or gateway layer, again everything is program only. Okay. Even in FPGA, if you want to configure your gates, you have to write a program only. So again, it's a coding. Okay, you need to write a coding, and you need to. There will be lot of gates available, and you need to fuse which one will be act as what. There will be lot of AND gate or gate, everything, right? So for an easy application, you can do the programming in two ways. One is either by coding, another one is by doing a sort of modeling in the as a circuit, and after that you can convert that circuit into codes, and that code again you can fuse it into the program. That's what, if you take I think in the embedded lab and all, you might have doing a Xilinx Patron 6. Okay. So in that, what you'll be doing, for example, if you want to do an adder or subtractor, you will be just picking your OR gate, AND gate and all. You'll do all the circuitry, and again you will be once everything the simulation is done and you'll be getting the results, there is an options to convert as a code. You can download as a code, and that code or that program you can directly fuse it, right? So that is what is program. Even though if I'm saying it's a hardware, but still the working you have to do it in a program only. Okay, sir, thank you. Any other queries? I think okay, so can you quickly, anybody can recap what we have seen, what we have studied in this session? Because it's a vast area, so I thought it's just a technical aspects only. I'm not touching upon any of the processor architecture or the programming that and all. It's just how the FPGA is applicable and how it could be able to, you can deploy to different layers of IoT. That's the idea. So to just verify whether the outcome is met or not, can you quickly recap what we have seen in this session? How we started the session? If you have any queries also, I'm happy to answer. FPGA and its features, IoT gateway, power companion, yes sir. Then FPGA and IoT, applications of IoT. Okay. Okay, if you have any queries, I think I've conveyed all the informations what I wanted to convey. If you have any queries, I'm happy to handle. I'm happy to answer. So these are some of the references which I took. Usha ma'am. Yes, I will give it to the organizer. You can get it from them. If you have any queries regarding this particular content, I'm happy to answer. With respect of the case study, is it possible to implement FPGA in human man? No, so to see implantation, it's very, see, every time, Saravanakumar sir, for implantation, uh, it's it gives more risk to the human being, right? So we want to ease our life. So for that reason only we are moving in for this kind of technology. So without actually operating, so how you place a pacemaker? So through surgery only they'll be doing open surgery and they'll be implanting that. So again, that's a foreign body that many times it may fail, and even due course of time after 5 years or 10 years, again they have to redo the do the re-surgery and they have to change the pacemaker, right? So this and all, it's very risk to the patients, because probably at the age of 40 they're be capable of doing all sort of implantation, but after 10 years, means at the age of 50 again doing open heart surgery, it's not advisable even at this particular lifestyle, right? So to avoid all such of implantation only, we will be checking in for the alternative ideas, for which we will be using this kind of applications. Saravanakumar, is this your query? Am I answered your query? Or otherwise, did I misconceived it? Is this your query, or you wanted to ask a different query? Implant FPGA is implantation of FPGA only you're asking, right? Saravanam, sir? Okay. So that's what, to avoid the implantation only, we'll be looking in for the alternate technologies. For that only, we are using this thing. Okay. Any other queries? See, because this session is more like factual information, so I thought no need to dump so many things. So that's what I've planned this way, so that I can give more time for the audience to ask questions and to clarify their doubts. There is any queries or any, because it's just a sharing of information. So even I can also learn from you, right? So that's the reason why I kept this information session or interactions. If you have any specific queries, I'm happy to take. Usha ma'am? Yes, yes, sir.
Yes, ma'am. So the session is so nice and very interactive also.
Thank you, sir.
Participants, if you have any more queries, you can post it in the chat box.
Yeah, if you have any queries, you can ask. Otherwise, okay. Otherwise, thank you. I would like to thank all the participants. You're all very interactive. and I'm happy to take any queries in this juncture.
Okay, ma'am, I think there are no other queries.
Okay. I think we have 20 more minutes, right? Okay. So if you don't have any queries, then okay, I have done with my job. Usha ma'am?
Sure. And Usha ma'am is going for an academic
Okay.
work. She will be back just a minute.
Yes, okay.
Okay, ma'am, we shall wind up the session now. So,
Yeah, thank you. Thank you so much. And if you have any queries, you please feel free to write a mail. Definitely, I'll get back to you. Thank you. Thank you, sir.
Sure, thank you.
Thank you so much.
Participants, the next session will start by 11:50. We can be in the meet. So by 11:50, the session will start. Janaki, thank you again.
Thank you. Thank you so much, sir. Thank you.